start talking about what we're going to talk about today. So we're almost finished, and I've got lots of grading that I'm doing on tests as they're coming in. Remember, test 3 is remember to send that to me. I'll try to get test 4 put on line today, just so you can be taking a look at it. Well, actually, it'll probably be set up so that once you log into it, you have to take the test. So I probably wouldn't log into it unless I'm ready to take it. And we still got a few more concepts to go over. We're going to talk today about displaying data in 2 ways. I want to focus on these 2 ways because they're somewhat related. Then next time we're going to talk about summarizing data with numbers, so like with a mean, median, mode, things like that. And then the final thing we'll talk about is the normal distribution. And then after that, it'll just be catch up. So what I want to do first is I want to show you some things. I've updated the course outline, and we probably won't have the going over stem and leaf plots and histograms today probably will not take us the whole time. Hopefully it will not. So I want to take a little bit of time to tell you about the rest of the semester. So I'm going to stop sharing this actually, and I'm going to start sharing my screen. Well, I guess I can't start sharing the screen because I'm using Edge, and it says that sharing the screen is only available on Chrome, Firefox, or, well, no, it says Edge. I should be able to share the screen. Oh, well. Well, it's not letting me. Maybe I'm with Internet Explorer. I don't know. It doesn't matter. So anyway, well, let me just tell you this. Go online at myopenmath.com and look for the course outline. It's new, and the course outline will show you, tell you everything you need to know about the end of the semester. Okay. So let me go ahead and share my document again, and we will get started talking about this. And like I said, Braden, I see that you left because you had bad connection. Well, you can look at this later. If you log back on, that's great. If not, we can look at this. I see that you were here. You can look at this later when I get it posted, and I'll try to post it today. If I don't forget, this is a busy time and I forget some things. But anyway, all right. So let's talk about some ways to display data. So last time we talked about how to collect data and how to do it so that your results will be valid. Now today, after we've collected data, we want to be able to display it so we can start to analyze it and take a look at it. So it says, after data has been collected through an observational study or an experiment, we need to summarize the data so it can be analyzed and interpreted. One way to do this is in a frequency table. And a frequency table is a table that lists the category or specific data value in one column and the number of times that category or value occurs in the data in a second column. So if you're dealing with categorical data, you may have something like eye color may be the variable you're looking at, or it may be the characteristic you're looking at. So you might have blue, green, brown, and then in the second column you would have how many people had blue eyes, how many people had green eyes, how many people had brown eyes, and so on. So that's basically a frequency table. We're going to be looking at this for mainly numerical data. So either we're going to have one data value and the number of times that data value occurs, or we're going to have a range of data values. So if we're looking at number of credit hours, I might say that the first row in my chart or my table would be somebody who has from 0 to 6 credit hours. And then I would list the number of people that have within that range. Okay, so let's look at this situation. It says, while taking a scenic nature walk, you are overcome with the desire to determine the average height of the beautiful flowers you see. So you're walking along this nature walk or nature trail. You want to find out or discover what the average height of the flowers on the trail is. So if you pick a flower randomly, what will its height probably be is what we're looking at. I don't mean pick a flower like pick it and take it away from the ground. I just mean choose a flower. You know that when sometimes I've been out walking and hiking in the sort of in the mountains or like like some trail in the woods or something. If you see a flower, you should never ever pick the flower, especially if it's the only flower of that kind that's around, right? So what I usually do is I usually take a picture of any new flower, interesting flower that I see, and then I bring it into the college, and I have some colleagues who are botanists, or they study plants, and then I ask them, I was like, well, what do you think? What is this flower? Is this something that's common? I've just never seen it before. Is this something that's rare? But anyway, that's getting off topic a little bit. So you pull out your measuring tape because you want to measure the heights of these flowers and notebook and record the following heights. Now these are in inches of random flowers you see along the trail. So we have 11, 33, 42, 50, 12, 34, 42, 50, 13, 35, 43, 51, 21, 35, 43, 43, 37, 21, 24 inches, 37 inches, 11, 24, 27, 21, 35, and 43. So we can organize these heights into the following frequency table. So just because this is very simple, what I'm going to do at first is I just list all the heights that we measured. And then in the second column, I put the number of times that height occurred. So I found 2 flowers that were 11 inches tall, so that gets a 2. I found 1 flower that was 12 inches tall, one that was 13 inches tall, right? So most of not most of, but the largest frequency that I have in the table is 4. So there were 4 flowers out of the, how many is here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So 4 out of the 26 flowers were 43 inches tall. So anyway, that's cool. And then I had several that were just 1 frequency. The lowest height that I had was 11 inches. The highest was 51. So we can represent this data even more concisely using a diagram. That should be a diagram. Called a stem and leaf plot. So in a stem and leaf plot, we separate the digits of each data point into the rightmost digit versus the rest. So the ones place becomes the leaf, and the rest of the number becomes the stem. And we can express the above data in a stem and leaf plot, and I'll show that in a minute. Let me tell you what I mean by breaking this up. So when you have a stem and leaf plot, what you're going to do is each data value, you're going to break it up into its ones place and the rest of the numbers. So here I have 11, 33, 42. So basically here, what I'm going to have is I'm going to have 1. I'm going to break up 11 into 1 and 1, right? I'm going to break up 33 into 3, which is the ones place, and then the rest of the number, which is 3. So these are 2-digit numbers, so we're just going to split them apart. If I had something like, let's say I had something like 462 and 463 and 421, then I would break this up into 46 and 2, 46 and 3, and 42 and 1. So what we're going to do is once we break up all these numbers, we're going to put the value on the left behind a long vertical bar, and we're going to call that the stem. Then what I'm going to do is I'm going to attach the leaves that go with each stem. So in this group of numbers, for example, if I have a 1 here, let me go ahead and clear this, and I want to show you what I mean. So in this group of examples, I have a 1 that's part of a stem, okay? So that we're going to call that part of the stem. So then every number that begins with a 1 will be listed after this 1, and we're going to call each of those a leaf. So I have an 11, so that's 1 and 1. So 1 and 1 is 11. I have another 11, so that's another 1. So these two 1s are the leaves, and that tells me whenever you see this, if you don't have the data or you don't have the table, what this tells you is that I have an 11 and another 11. And then I also have a 12, so I'm going to put the 2 there. So that's telling me that I have a 1, 2, I have a 12, and then I also have a 13. Then I also have numbers with a 2 that are in, numbers that are the 20s. So when I look at that, I look for all of my numbers that have a 2 in the front as the tens value, and I record the ones value. So that's 21, so I put the 1 there. And another 21, so I put 1 here. And 24, right, so I can put a 4 there. Usually you put these in order. And another 24. And I also had a 27, and then another 21, so I might insert that one right there. Okay, so this is the stem, and these are all the leaves. So when this is finished, the stem and leaf plot looks like this. So here we go. So this tells me that I have a 1, 1, so an 11, 11, a 12, a 13. I have 3 21s, 2 24s, 1 27, 1 33, 1 34, 3 35s, and 2 37s. I have a 42, another 42. I have 4 43s, 2 50s, and a 51. So that's the stem and leaf plot. So this is the stem. I'll do this in green. And these are all the leaves. So now you can tell a lot from this. I can tell that most of the values are in the middle, right? Most of the values are, well, I have more plants with a height in the 30s than I do anything else. Don't have very many plants that are very small or very large. Most of the plants are around what we might say 30, 35 inches tall, right? So another reason why a stem and leaf plot is interesting is because if you turn the stem and leaf plot on its side, it basically has the same, actually that shouldn't say has the same, cross that out, so on page 2. It doesn't have the same, but it basically becomes something that we call a histogram. So here is a stem and leaf plot for the above data on its side, and you can see it looks like sort of like a bar graph, doesn't it? Well, a histogram is a bar graph, right? Do you remember those from some other classes that you may have taken? It's a bar graph, but the sides of the bars are touching. So notice here how the sides of the bars are touching. In a histogram, the data values are grouped into intervals. usually called classes. So what I did here was basically I just said that all the numbers that were in the tens were a class, all the numbers that were in the 20s are a class, the 30s, 40s, and 50s. So a class will be from 10 to 19, from 20 to 29, from 30 to 39, 40 to 49, and 50 to 59. Okay? And each bar represents the number of data values in that interval. So for our flower data, a histogram would look like this. And what you usually do is you make a frequency chart with, instead of each of the values listed, you write the class. And this helps you to draw the histogram. Now, you may, if you go into Excel or if you go online and you try to create a histogram, there are some sites that will create a nice one for you, like the one that I have here, and I forget what site that is. But if you try to go to Excel or if you try to use some sites, there's just something about a histogram that technology, for the most part, doesn't really get it yet. So if you go to Excel to try to create a histogram, it won't. Excel has a histogram, Excel has a histogram option, but it doesn't create a histogram for you. If you want to, if you don't want to create it yourself, my advice would be to go on to Google, just type in histogram creator or histogram plotter or something like that, online histogram creator, and see what you get. Don't try Excel, because Excel is not going to work. The best you could do with Excel is to do a bar graph and then manipulate it a little bit, but it's just not worth it. Either draw it yourself or go online. So what you'll notice is that in a histogram, a bar represents the values on the horizontal axis from that on the left-hand side of the bar up to, but not including, the value on the right-hand side. So here, from this class right here, 10 to 20, it's actually not 10 to 20. This is really 10 to 19. And then 20 starts the new one. So 20 to 30, right? And it's not really 20 to 30, it's really 20 to 29. So 30 starts the new one. So these are all not included. Like this 20 is not included in this first bar. 30 is not included in the next bar. It's included in the other one. 40 is not included in this bar, the bar to the left of it. It's only included in the bar to the right. So that's how we generally traditionally look at a histogram. And then also 50 is not included in the bar to the left. It's included in the bar to the right. So for example, in the above histogram, a data value of 20 is considered to be in the second class and counted with the values in the second bar. Also, the classes are usually equal size. In fact, they are, I say usually equal size. I can't think of a reason why they wouldn't be. So the classes are of equal size. You'll notice each of these have 10 numbers in them. And the frequency may not be equal, but the classes themselves are equal. And a histogram is made up of between 5 and 20 classes usually. So it's tradition to have a histogram be between 5 and 20 classes. You'll notice that we have 5 classes in ours. The modal class of a histogram, or a stem and leaf plot basically, is the class that contains the most values. And has the highest frequency. So what is the modal class in this case, in this histogram? Well, it's the one with the most values, the highest frequency. So the modal class here is 30 to 39. So for our video, not our video, sorry, I'm getting an email and it's popping up on my screen, it's distracting me. So for our group of data, or our data values, the modal class is 30 to 39. All right, so we can classify histograms based on their shape. So if we have a histogram that looks like this first one, and what we're gonna do is we're gonna call this the sort of smaller or the shorter part the tail. So this is the tail. This is the tail of this histogram. This histogram doesn't really have a tail, does it? And this one has two tails, right? So this is the tail. So if you have a histogram that has a tail to the right, that histogram is called right skewed or positively skewed, or skewed to the right. If a histogram is right skewed, most of the data values tend to be smaller. For example, if this is the representative of all the guests at Matt's Cafe, based on their age, we realize that there are more guests between 30 and 40 that come to Matt's Cafe than there are guests between 80 and 90, right? So there are more younger guests than there are older guests at Matt's Cafe. Math, I don't know why I said Math Cafe. But so if I were doing a statistical study based on this histogram, some of the questions I might ask is, well, what makes Matt's Cafe more appealing to younger guests than older guests, right? All right. If we have a histogram that has a tail to the left, then we call that left skewed or negatively skewed. If a histogram is left skewed, most of the data values tend to be larger. For example, second. Okay. Most of the data values tend to be larger. So, for example, it says there are more pennies with the year 2019 on them. If this is the dates on pennies, number of pennies, and the date, there are more pennies with the date 2019 on them than there are with the date 1960, right? Because 1960, very, very few, less than 10 or less than 5, right? 5, 10, 15, 20, yeah. And then 2019 to 2020, well, 2019 would be in this block, right? And there's a little bit over 55. All right. So a histogram where all the bars are very close in height is said to be uniform. So this is uniform. The data values represented by a uniform histogram are evenly distributed. There is, that should be there. Sorry. There's roughly the same amount of values in all classes. I need to proofread these better. All right. And finally, if I have a histogram where the bars are approximately symmetric around the middle bar, so there's a middle bar and it has most of the data values, the middle bar does, and the rest of the data or the rest of the bars are sort of approximately symmetric. Even though these aren't the same, they're about the same. These are about the same height. So I would call this approximately symmetric around that middle bar, and the middle bar does have the most values. We call this bell-shaped. And you can see that because it looks like a bell when I draw a line. Now this image right here will be very important to us later on, and this histogram, or the way that these values are distributed, data values are distributed, will be important to us as we move on. So look for more, look for that later. The data values tend to center around a value in the middle, and we'll talk more about what that value is later next time. And there are not as many very small or very large data values, right? So age, this is the number of the retirement age of each guest at Logan Assisted Living. All right, so these are people at an assisted living. There are not many people in their 30s or 40s that are living with Logan Assisted Living. There are not many people in their 90s. There are lots of people in their 60s and 70s. So then you might ask the question, why would there not be many people in their 30s and 40s living there? Well, because people in their 30s and 40s, they probably don't need assisted living, right? They're not to the point where they need someone to help them get through their daily lives. Why would there not be, this is kind of gruesome or depressing, but why would there not be many people in their 90s or who are 100 years old? Because there are not many people who live that long, right? All right, excellent. So what I have is two situations for us, and I think we can finish up these and before time even. But let's consider the following situation. So below is a list of final grades for the students in a class I taught last semester. Create a stem and leaf display to represent the scores. Okay, so the first thing I want to do is I want to look to see what the numbers, what the tens digit in these numbers are, or is. So I have an 8, I have a 7, I have a 5, a 6, a 9, a 6, and that's it. So I'm going to put these in order. I'm going to start with 5. I'm going to have 5, 6, 7, 8, 9. So 5, 6, 7, 8, 9. And this becomes my stem. Now I'm going to put the leaves. So here I have an 80. So I'm going to put a 0 after 8. I have a 70. So I'm going to put a 0 after 7. I have a 71, so I'm going to put a 1 after 7. I have an 82, so I'm going to put a 2 after 0. I notice here that I have another 82, so I'm going to put another 2 after 0. I have an 86, so I'm going to put a 6 after 0. I have a 72, so I'm going to put a 2 after 7. I have another 70. I should have looked for that one because I like to put these in order. I'm going to sneak that other 0 right in there. Okay, I have a 51. Do I have a 50 in there anywhere? Nope. I have a 63, but the smallest, so I'm done with that. So the smallest that I have is a 62, so I'm going to put the 2 first, then the 3. Then I have 68 and 68. And I have a 90. I have a 66. Well, that actually goes right here. And you know what? You can list all these, and then you can go over in another one and put them in order if you want as well. Okay. So I already have that 66. I have a 95. I have another 72, and I have 2 more 86s. So I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 grades. And to make sure I've accounted for everything, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 in the stem and leaf plot. And there you have my stem and leaf plot. What is the modal class here? If these are the classes, the scores in the 50s and the 60s and the 70s, 80s, and 90s, what's the modal class? This is the modal class. The 80s are the modal class, right? Because they have 6 more. Let's see, 1, 2, 3, 4, 5. Yeah, more than any other. More frequency. All right. Okay, so let's take a look at another question. It says, at a certain college, the total cost of textbooks for the term was collected from 36 students. We want to create a histogram to summarize this data and identify the shape of the histogram. Okay? So let's look at this data now. What I would like to do is, rather than just list a frequency table where I list like 140 and 160, let's go ahead and make the classes. So here's one way that we can look at making the classes. I'm going to look at the lowest dollar amount that I have and the highest dollar amount I have, and I'm going to subtract those. So I've got 460 minus 140. That's going to give me 320. So remember, I want between 5 and 20 classes. 320 is divisible by 5, right? So I'm going to say 320 divided by 5 and that gives me 64. So what I can do is I could have 5 classes. So excuse me, sorry for yawning. I could have 5 classes with 64 possible elements in each class. So I can have 5 classes of 64 each, size 64. You could divide 320 by 10 to get 32. So we could have 10 classes with 32 possibilities in each class. I don't know if there's anything else. We could, 320 is divisible by 2, so I wouldn't want 160 classes, so I wouldn't use that, but that's basically how I would do it. I would just look and I would say, I noticed here that this was 0, so it's divisible by 5, so let's break this up into 5 classes, 64 possible data values each class. So I'm going to create a frequency table here with the classes instead of just the numbers. So class and frequency. So let's abbreviate frequency as FREQ period. Okay, so the first, I'm going to start out with 140. So the first class is going to go from 140, and I'm going to go 64 more 64 more data values in that class. So I have 140 to 204, right? So all I did was I said 140 plus 204. Next, I've got 205 will be the next number. And I'm going to add 64 to that. So 205 to 269. Um, so I'm going to the next class will be 270. All the way to 334. And actually these may be 65. These classes may be 65. Because I have 140, right? And I add 64 to it, so I have one number already in that class. But that's okay, as long as these classes have the same amount, then that's fine. As long as they're the same size, that's fine. It doesn't matter how you break them up. Okay, so then I'm going to start with 335, the next number up. And when I add 335 to 64, or 64 to 335, I get 399. And then when I add, the next number is 400. And then when I add 64 to that, I get 464. Okay, so now we want to look at the frequencies. So we're just going to do this like we did before. I'm going to first of all use tally marks, and then at the end I will add up the tally marks. So 140, that goes in this class, so I'm done with that. 160 goes in this class. Another 160 goes in this class. A 165 goes here. A 180 goes here. 220, that's going to be the next class. 235 is in this second class. 240 is in this second class. So is 250 and 260. So 250 and 260. 280, however, is in the next class. 285 is in this next class. Another 285, two 285s is in this next class. So 1, 2. 290 is still in this class. 300 is in this class still. Another 300 and the 305 and the 310 and another 310 and a 315 and another 315 and two 320s. So this one has a lot in it. 330 is still in this class. 340, nope, it's going to be in the next class. 345 and 350 are in the next class. 355 and 360 are. 360 and 380. 395. 420, however, is in the last class. And then two 460s. And now I have my frequency table. So I have 1, 2, 3, 4, 5. So 5 values from 140 to 204. I have 1, 2, 3, 4, 5. 5 values from 205 to 269. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 values from 270 to 334. I have 1, 2, 3, 4, 5, 6, 7, 8. 8 values from 335 to 399, and 3 values from 400 to 464. So let's see, is that 36, 8, 9, 10, 11, 26, 36. Yep, there's 36. So now let me create the histogram. So I'm going to create a histogram, and you know, my record with this using this mouse to draw is not going to make this as nice as it should be. But I'm going to start with 140, and then I'm going to go all the way over to 205. Remember that the histogram, this first bar is only going to include 140 to 204. And then I'm going to pick up 205 all the way over to 269, and these bars should be approximately the same width. Actually, I'm not going to go over to 269 because I'm going to start at 270 based on the tradition of writing the histogram. So I'm actually going to do 270 here. Then I'm going to go over to 335. And finally, I'm going to start at 400, and I'm going to end at 464. Okay, now over here, let's see, I have 5, 15, 8, 3. Let's count by fives, and I'm going to have 5, 10, 15, 20. And again, if I had graph paper and I could make this really nice, I would. Yours is going to be really nice when you create it. So now I'm going to draw my bars. All right. So I have, in the first class, I have 5. So I'm going to go up to 5, and that's that bar. In the second class, I have 5 as well, so I'm going to go up to 5 and come down. In the next class, I have 15, so I'm going to go up to 15 and come over. In the next class, I have 8, so that's 10. So it's a little less than 10, so it's probably maybe right here. And I have 3, so that's probably a little less than 5, so that's probably right here. So there's the histogram. From this histogram, you can tell that most of the values are around a middle value, right? There are not many people, or there are not many textbook amounts that are very, very low and very, very high. That makes sense, right? I wish there were more that were low, because that would mean that students would save money on their textbooks. But what would you call this histogram? I would call this bell-shaped. Even though it's not exactly symmetric, I would think that this is bell-shaped. All right, so we're done a little bit early today. What I'd like for you to do is check out the course outline. It tells you how the rest of the semester is going to go. We have a couple more sessions on Blackboard. Then it'll just be catch up on homework and take the 2 ending tests. Remember, if you haven't turned in test 3, please get that to me as soon as possible. And I know that some of you have been asking me what your grade is. I'm working on those, getting everything calculated, and I'll let you know soon. But anyway, have a good rest of the day, and I will talk to you on Wednesday.